All right, so we're going to look at example 3 and example 5, which we didn't get to Monday. So example 3 here, oh geez, pens, out of the header, is r equals 2 sine of theta. And so what we're going to do is we're going to draw out the sine curve, but only up to pi here, because when we're multiplying it by 2 here, it does something to the curve. So we're only going to be needing to look at half of the normal period, and we'll see why. But to figure out the r values with theta inputs, we're going to evaluate sine for our theta inputs and then multiply by 2. So these are values that you can figure out using Desmos, using any trig table like the ones we developed earlier this year. So if we're looking at 0, sine of theta, sine of 0 is going to be 0. So 2 times 0 is going to be 0. So if we go out 0 here, we're going to be at 0. Let's just say 1, 2, 3, that this is going to be our 1 radius, our 1r. And then 1, 2, 3, 4, this is going to be 2. And the reason that is because when we have 2 sine of theta, we're only going to have an r value that's ever as great as 2, because that's our amplitude. So sine of pi over 6, sine of 30 degrees is going to be 1/2. So 2 times 1/2 is going to be 1. So when we come out here to pi over 6, we're going to have this value of 1 right there. Pi over 4 is 2 times square root of 2 over 2. It's going to be square root of 2, which is approximately equal to 1.4. You can validate this using Desmos here. So let me see, it's 1.4-ish. So that means when we have pi over 4, we're going to come out to just about 1.4. So let's make these in red. Maybe that'll be a little bit easier to see what's happening. Sine of pi over 3, sine of 60 degrees is going to be square root of 3 over 2. And so 2 times square root of 3 over 2 is square root of 3, which is about 1.7. Validating that here. 1.7, a little bit more than that, but let's come back here and let's put that on our graph. So it's going to be right about there. And so we start to see this curve take shape. Pi over 2, sine of pi over 2 is going to be 1. So 2 times 1, which gives us 2, which gives us this value here. Connect that. Starting to see the shape take form. And then we start repeating our process because sine values in the first and second quadrant are positive. So this is very symmetrical in the sense that sine of 2 pi over 3 is square root of 3 over 2. Square root of 3, 1.7. So we have this value that's 1.7. Sine of 3 pi over 4 is square root of 2 over 2. Square root of 2, 1.4. So we put that, and that's halfway between here. So that's right about here. So we're starting to see this curve. Sine of 5 pi over 6 is 1/2. So 2 times 1/2, which is 1. And so 5 pi over 6. And then lastly, the sine of pi is 0. So 2 times 0 is 0. And we notice that we come back to center right here. And we get a circle. And you can validate this using Desmos as a graph. And if we go back here and I type in r equals 2 sine of theta, and there is our circle. If we change this to a polar grid, then we see exactly what we did, where we have a rate, we come out to 2 here, and we start at our origin, and each of these values are accounted for. All right, so let's take a look at the next example. So this next example, example 5, it's called a lemniscate or lemniscates. And this one is in the form, we have r equals cosine of 2 theta. So this is different because our input is multiplied by 2. So we do want to go the full distance between 0 and our period, which is 2 pi. And we're going to double our input here. So just for the sake of being able to leverage our technology, I'm going to put these values into Desmos. And I'm going to go through and do each major input value, which is any, it's our 0, 30 degree, 45 degree, 60 degree, 90 degree, and so on. But I'm going to write these in radians. So I'm going to go cosine of 2 theta. Let's do it like this. Okay, so 2 theta. And so I'm just going to copy this and paste it. So we're going to do 0 here. Oops, 2 times 0. So it looks like our first input is 0 for our theta value, and r is going to be 1. So we're going to go 1. Okay, let's go back. I'm going to do pi over 6. And it looks like our output is 0.5. So I'm going to go 0.5. Let's go back. So now our input is pi over 4. Our output is 0. Oops. So I'm going to graph this as our first leg of this experience. So we've got 0, and then let's make the full distance 1, so that we can go 1, 2, 3, 4. This can be 1/2. So when we do this, I've got 0, 1. I've got pi over 6, 1/2. And then I've got pi over 4, 0. So what happens for this first leg is we come like this. So let's call this 1, and then this is 1. Okay? And so we're going in this direction like this, like this. And then our next leg, let's do pi over 3, negative 0.5. Negative 0.5. And then pi over 2, negative 1. Okay, then 2 pi over 3. Negative 0.5. Okay. And let's call this leg 2. Remember that when we have r values that are negative, so if I'm at pi over 3 here, if it's a negative 1/2, I would go here, but then I'm flipping it. So I'm going to go 1, 2, 3, 4. So I'm going like this. And then I have pi over 2, 1, but it's negative, so I'm flipping it, and I'm going right here. So I go like, and I'm going like this. And then negative 1/2 again for 2 pi over 3, which is 2, 3. So negative, or so that's 1/2. Flipping it. I'm going like that. Oh, and then let's do 3 pi over 4 just to round this up. 3 pi over 4, which is 0. So 3 pi over 4, it's going to be 0, so I'm going to come right here. So I'm going this way, this way, this way, this way. Okay, so then let's go 5 pi over 6. This is 0. You stretch that. 5 pi over 6. Let's go blue with this one. Five pi over 6 gives me 0.5. Okay. So if I go 5 pi over 6, and then 4 pi over 3. Negative 1/2. Oh, silly me. I meant to go to pi. Sorry about that. 1. Okay, so pi is going to be 1. So if we're going out to pi, we're going out to 1. So we come out like that. And then now we want to do 5 pi over 4, which is this guy right here. This, where are we at with 5 pi over 4? 0. Oh, 5 pi over 4 is right here, and that's 0. So I missed one. We missed 7 pi over 6, didn't we? Sorry about that. 7 pi over 6. Okay, 1/2. That's what we wanted. Okay, so we're coming back right here. And then we're coming back to 0 at 5 pi over 4. So far, maybe we go light blue with this. We've got this, we've got this. Okay. And then you might be able to deduce what's happening the rest of the way, but we'll continue. So let's go 4 pi over 3. Okay, negative 1/2. Let's go 3 pi over 2. Negative 1. 5 pi over 3. Negative 1/2. And 7 pi over 4. 0. Okay, so I'm already seeing kind of a pattern here. Let's go pink with this one. So 5 pi over 4, 0. 4 pi over 3. Oh, kind of did that. 3 pi over 2 is negative 1. So negative 1 for 3 pi over 2, but since it's negative, we flip it. And I think we had this 4 pi over 3. Did I skip that one? No, this should have been a negative. So since it was negative 1/2, we go 1/2 and then we flip it. And then same with 5 pi over 3. We go 1/2, but we flip it. So then we're following this trajectory. And then finally we land in 7 pi over 4, 0. All right. Seven pi over 4, 0, and then 11 pi over 6. We also need 5 pi over 3. 5 pi over 3 is negative 1/2. Oh, we did that one. Never mind. 11 pi over 6. 11 pi over 6. 1/2. Oops. And then lastly, 2 pi. I put 2 pi in there. 1. So 11 pi over 6 is 1/2. So 11 pi over 6 brings us out to 1, 2, 3 to 1/2. And then 2 pi brings us out to 1. So what we get is this rose shape here. And if I start out in the purple, it starts out here. And right there. And then we continue. So let's double check this in Desmos. And so if I plot r equals cosine of 2 theta, there we go. You'll notice that we come out to 1. And we start off over here at 0. And as we go around the circle, we go down. So I hope that was helpful, and I'll share these notes on Schoology. Let me know if you have questions.